I believe we're rolling. Alright, that should be good then. Right, my last video was covering logarithms, solving simple logarithms. It was just, the standard notation and what a logarithm was and the standard formula, to convert them. But in this video we're going to be looking at natural logarithms. We're not going to be looking at the graphs still, we're saving that for another video because that deserves its own video. But we are going to be looking at using these in equations. We're going to be looking at solving these 3 questions specifically, and by the end of this we should be able to do these because they're quite good. They're not too bad. But I got these questions from the Madders Maths site, so Madders Maths, shout out to them. But this is question 14, 15 and 16, so if you can't really see them you can pull it up on the side and you can do them along with me. But yeah, these are the 3 questions we're going to try and learn how to do today. So I want to begin by saying what ln is, what the natural log is. So ln is essentially just like any old logarithm. It has a base, it has, your number, you have a, n equals p. But with a natural logarithm, all it means is it is a logarithm with the base e, the exponent. So ln is equal to log e, basically. That just means log base e. So yeah, that's all natural log is. It literally just means log base e. And so when you use this, that ln there, that just means log base e 7 to the x is equal to log base e 10. So it's not too bad, it's not complicated at all. So that's all ln means. You don't really need to know much more than that for solving these little equations and such. But we're going to look at how we can use these. So I think in question 14 actually, it was just 7 to the x equals 10. So we'll actually cover that right now. If you have a number, say 7 to the x equals 10. Now, what you can say is the logarithm, or the natural log of 7 to the x is equal to the natural log of 10. Because they have the same base, and yeah, that's equivalent. That's equivalent to that, so that means the same thing. And you can actually now use this, because obviously from our last video we know that if you have, say, log base 2 of 2 to the 4, that's equal to 4 log base 2 of 2. You just bring the power down to multiply the logarithm. So log base 2 of 2 to the 4 is equal to 4 times log base 2 to the 2. Okay? So now, looking at this, we can solve 7 to the x equals 10 quite easily. You just do the natural log of 7 to the x equal to the natural log of 10. And doing that, you can just go, because this is like any old log, you can do x times the natural log of 7 equals the natural log of 10. Okay? And once you've gotten down to that, it's quite simple. That's just, there's a little times symbol in here. So you have x times the natural log of 7 equals the natural log of 10. So how would you solve for x? Well, if that was, say, x times 2 equals 10, then, what you do, you just divide by 2, wouldn't you? You divide that by 2 to get x. So that's what we're going to do up here, because we're treating this like any old number. We're just going to do x equals ln 10 over ln 7. Okay, and now all you can do with that, all you have to do, it's what you can do, but all you have to do to solve that is quite easy. You just put that in your calculator. If you have the Casio FX991, like I do, you press catalogue, function analysis, and you go down to natural logarithm right there. Okay, and then you just do it. You just do ln 10 divided by, go through function analysis again, natural log of 7 right? And you get 1.18 to, 3 significant figures. So that is just equal to 1.18. So x equals 1.18. And now that is basically the fundamentals of this. The rest of the problems sort of just break down into this. You just use this to solve them. So we're going to solve question 15 and 16 now. We're going to see how we can use, the logarithmic formulas and logarithmic rules to get through them. But that's all you really need to do with natural logs for solving the equations. About the graphs and everything, that's all you really need to know right now. So ln just means log base e. That's all you need to know. And you treat it like any other old logarithm. But yeah, it has a special place on your calculator. You can just find it in function analysis if you're using the Casio. And yeah, they're quite good, quite fun. So we're going to move on to question 15 now. We're going to see how you can solve that. I'll write it out a bit bigger for you to see. But question 15, remember you can find these on Madders Maths, the website, if you want to see them a bit easier, because obviously I know my writing's not the best. But yeah, log base 2 of y equals 9 over log base 2 of y. So how would you solve this? Well, you'd treat this like any old number right now, and you just multiply these two, get rid of the denominator on that side. So you get log base 2 of y squared equals 9. Okay, and now how would you solve this? It's quite easy. You treat that like, say there was no log there, that was just y, so you have y squared equals 9. How would you solve that? You would just square root 9, wouldn't you? And you get y equals plus minus 3. So we're going to do that for log base 2 of y up here. So you get log base 2 of y equals root 9. I'll move out the way in a sec. Which is equal to plus or minus 3. Because remember, if you square minus 3, you also get 9. So it can be either positive or negative. And now we have to solve for both of those values. So we have log base 2 of y equals minus 3 or 3. Okay? I'll just rub out all this top bit here so we have a bit more room to work with. We're still doing the same question. So log base 2 of y is equal to minus 3 or 3. Okay? So now how do you solve that? Well, quite simply, you take each value and you get log base, we'll start with regular 3 is equal to 3. Okay? How would you solve that? Well, you can do something similar as we did before, because originally on the question I forgot to do this, but they didn't have the natural logs. Obviously, we add on the natural logs to be able to solve that question. So here, what we have to do to solve this is we can't get rid of the log on this side, really. It's much easier to just add a log onto this side. So how would we do that? Well, to use these equations, they obviously need the same base. So we know this has got to be multiplied by something which is to the base 2. So log base 2 of y is equal to 3 times log base 2 of 2. Now you're probably thinking, where did you get that from? Well, the thing is, log base 2, right, of 2 is equal to what? Just equal to 1. So this 3 times log base 2 of 2 is the same thing as just 3 times 1, because that is equal to 1. Yeah, that's the same as 3 times 1, which is exactly the same, it's just 3. So now this looks much nicer, doesn't it? We can solve this quite easily. You have log base 2 of y is equal to 3 times log base 2 of 2. So you have log base 2 of y is equal to log base 2 of 2 cubed. Okay? So now you get y, you can just get rid of the log base 2 there, you get y is equal to 2 cubed, which is equal to 8. Okay? Hope you saw where I got that from. So log base 2 of y, you can essentially just annihilate the log base 2's because they're on both sides here. You just divide both sides by log base 2, I guess you can think. And then you get y is equal to 2 cubed, okay? Y equals 2 cubed, 2 cubed is equal to 8. So one of our answers, 1, is y equals 8. So we have y equals 8 over here. And now essentially you just do the same thing for minus 3. Yeah, so I'm not going to go through all the little details in this one, but we'll get an answer is equal to minus 3. So you have log base 2 of y is equal to minus 3 times log base 2 of y. No, log base 2 of 2, my bad. And then you get, y is equal to 2 to the minus 3. So y is equal to 1 over 8. So y is equal to 8, or 1 over 8. And that's our solution to question 15 right there. And now there's one more example. This is, I think, the trickiest out of the three personally. So yeah, there's one more example that we can go through here, which is number 16. And something a little unique happens here with number 16 as well, just like each one of these is unique. They're each a different sort of type, I guess you can say. So we have number 16. I'd recommend pulling this one up from the website, Mad as Maths, number 16. Just the logarithm questions. Because, it's quite big, I'm going to have to break it up a little. Minus log ax is equal to 2 log a 3. Yeah, so these are all to the base of a. So you have log a x squared minus 10 minus log a x is equal to 2 log base a 3. Okay, they're all base a. So now we know from our formula, if you have like log a2 minus log a3, that is equal to log base a of 2 over 3. Yeah, from our last video we know that. That's one of the formulas. So when you minus, you just divide by whatever's in the log. So log a x squared minus 10 minus log a x is equal to log a x squared minus 10 over x, which is equal to 2 log base a3. Okay, so we've ended up with that. Just get rid of that. And now we can say, we know that another thing, obviously we've seen these in the last couple of questions, so you probably noticed this almost immediately, but log a x squared minus 10 over x is equal to log base a 3 squared. So obviously you just bring that up to the power there. So now we've ended up with this. Just close my bracket there, don't be silly. So we've ended up with this. And now these are to the same base, so you can sort of get rid of them. You just sort of subtract log a 3 squared, which is just 9. Log a 9. You just sort of subtract log a 9 from both sides, so this becomes 0, and that becomes... wait. No. Right, don't think of it that way. Just, get rid of log a. That's all you got to do. Get rid of log a. So, we just do x squared minus 10 over x is equal to 9. Now that's just like any old algebra, you can solve that quite easily. So we'll wipe this out up here, just, absolutely nuke it. I got rid of question 16 in action, but it doesn't matter. Alright, so you get x squared minus 10 equals 9x. Because we're multiplying both sides by x to get rid of the denominator down here. And then you subtract 9x from both sides. X squared minus 9x minus 10 is equal to 0. Okay. I'll select any old quadratic. Yeah, x minus 10 and x plus 1 is equal to 0. Okay, that's the, so is it factorised for? The form in the brackets. But yeah, from this you get x equals 10 and minus 1. Now, that's really simple, and I'm sure, it wasn't too bad. But one thing you have to be careful of is x here, in this situation, cannot be minus 1. Because at the start of the thing, obviously at the start of the question, if you look at it, you have minus log a of x. Now, log a of x for any number, x cannot be negative. It's undefined, it's not allowed. So x actually cannot be minus 1. So in this circumstance, x equals 10. And that's our solution. So I'll write out the solutions real quick, just so you can get a little summary, a little look at them. But yeah, that's how you solve some more sort of equations, and how you can use natural log. If you have any number, say 8 to the x equals like 62, you just go natural log of 8 to the x is equal to the natural log 62, and then you solve from there, as we saw before with the 7 to the x equals 10. So yeah, you can just multiply by the natural log, or we'll find the natural log of them, and you use that to get to your answer of what the values are. But for 14 we got, it was like 1.18, wasn't it? 1.18. 15, I believe y was 8, 1 over 8. And for 16, we got x equals 10. So yeah, those are the solutions to those 3 types of problems right there. And I hope, it's inspired you to go do a few more, because I find these personally fun. I love doing these. But yeah, I felt a little more festive today, so I wore the little sweater, as you can see. But yeah, that's how you use natural logs and equations. That's how you solve those types of questions. And if you enjoyed this and you want to see more like this, tune in for the next logarithm video, where we'll probably cover some graphs maybe. Then obviously, I'm going to say subscribe, aren't I? Subscribe and hit the notification bell so you get notified when I upload. But yeah, if you want to see some of my other videos, I've done another log video before this, as I mentioned, and I've done some shorts which are festive challenges right now. If you want a few challenges, I might do a log challenge eventually, but they're mainly problem solving for most people to do. But yeah, I hope you enjoyed this video, and I hope you have a merry, jolly, happy Christmas. See you later.